So, greetings all of you. So as we know, GATE examination for mechanical engineering students was commenced on 1st February this year, and I hope all of you have done well in that. So right now we'll be trying to look at the solutions of questions from mathematics, okay, in forenoon session. So let's stay tuned and let's try to solve the questions. So my friends, if you look here, this is one of the questions in mechanical forenoon session from mathematics, and this question is from straight away limits. Okay, now this question is limit x tends to 1 minus e power minus c into 1 minus x divided by 1 minus x into e power minus c into 1 minus x. Now if you want to evaluate this limit, let us suppose this limit is equal to some value L. So we have L is equal to limit x tends to 1 minus e power minus c into 1 minus x divided by 1 minus x into e power minus c into 1 minus x, correct? So straight away if you substitute x is equal to 1 here, then 1 minus 1 is 0 and 0 into c is again 0. So we have 1 minus e power 0, 0 or minus 0, both are same. So or let us write minus 0. So this is equal to 0 divided by 1 minus, again this value is e power minus 0, and when x is equal to 1, this whole value is again e power minus 0, the value of which is also again 0. So basically this limit is giving you standard 0 by 0 form. So in case of 0 by 0 form, we generally apply our L'Hospital's rule. So applying L'Hospital's rule. And what does L'Hospital's rule tell us? Whenever any limit is giving 0 by 0 form or infinity by infinity, then he asks us to differentiate the numerator and denominator independently, correct? So therefore L is equal to limit x tends to 1, differentiation of this function with respect to x, differentiation of 1 is 0 minus differentiation of e power this function is e power minus c into 1 minus x into inner differentiation of this function is minus c into inner derivative of this 1 minus x is minus 1 whole divided by, let us close one more bracket here, so whole divided by, again differentiation of 1 is 0 minus, now if you see there are two functions involved here, one is x and the other is this e power minus function. So let us try to differentiate this function using our product tool. So first function into differentiation of second function, and we have seen the differentiation of this part is this. So let us repeat that, e power minus c into 1 minus x into minus c into minus 1. This is first function into differentiation of second function plus second function, which is this e power minus c into 1 minus x into derivative of first function, which is x is the first function here, so differentiation of x is 1. Okay, so now if you try to simplify the things, this is limit x tends to 1, this minus into minus is plus, and plus into 1 minus sign is again we have one more minus, minus c into e power minus c into 1 minus x divided by, look here, so now basically this is minus into minus is plus, and we have a minus sign here, so minus of this minus c into minus 1 is c into e power minus c of 1 minus x into x plus this function, so plus e power minus c into 1 minus x, correct? This 1 minus c multiplication is only for this c. Now if you look one thing very carefully, you have this e power minus c into 1 minus x common in all terms, so let us cancel this. Then what's the limit you have? This implies L is equal to limit x tends to 1 minus c divided by, you have minus of, there is c into x, cx plus we have 1 here because everything got cancelled. So L is equal to, this minus and minus gets cancelled, and when you substitute x is equal to 1 in this limit, you have c by c plus 1. So what is L? Initial approximation of this given limit. So we have L is equal to c by c plus 1, which is option C here, correct? So the answer for this is, or the option is option C. Actually we have done this complete analysis as per our basic procedure, but in mechanical engineering, if you have a little idea, you might know the formula for effectiveness of a counterflow heat exchanger. Counterflow heat exchanger is given by, this is equal to 1 minus e power minus NTU into 1 minus C divided by 1 minus C into e power minus NTU of 1 minus C. Correct? And where this C is the ratio of heat capacities. When the ratio of heat capacities of both hot fluid and cold fluid is 1, then means basically in case of C is equal to 1, this gives 0 by 0, and in that analysis, if you remember, you will be getting the effectiveness formula as NTU by 1 plus NTU. You remember this? So this is same as this question. If you look, 1 minus e power minus C into 1 minus x divided by 1 minus x into e power C minus C into 1 minus x. So here if you put NTU and in place of x you have C, this expression is nothing but effectiveness of a counterflow heat exchanger when it's coming 0 by 0 form. And in heat exchangers we analyze that this effectiveness when a value of C is equal to 1 gives this value which is equivalent as C by 1 plus C here. Thank you. Now we'll be looking at next question. Thank you. So we have seen just now our first question. So this is second question again which came in forenoon session. So find the area under the curve y is equal to integer part of x when x belongs to 1 comma 4. And you know this function which is x written in square bracketed is called greatest integer function. Correct? Greatest integer function. And by definition, what is the value of, what's the nature of this function? This integer part of x is equal to n for all n less than or equal to x less than n plus 1. And make a note, I put the equality sign only here but not here, which means for any value of x lying in between two integers, the value of this integer part x is nothing but this left integer which is bounding it. So this is the function. Now we want to find the area under this curve for in between, for x values in between 1 to 4. So if you try to plot this function 0 x y 1 2 3 4 5 1 2 3. Okay, now look, for example, you know, if I ask you what is integer part of 1.2, then the answer is 1 because this 1.2 lies in between this 1 and 2, and we told the leftmost integer as in case of n here, where n is the leftmost integer. So which means for every value in between 1 and 2, the value of this integer part function is 1, correct? If you take this as 1 and if you take this as 2. Similarly, for every value between 2 and 3, the integer part x function is, the value of the integer part x function is 2. Similarly, for every value in between 3 and 4, the integer part x value is 3, correct? So now he is asking what is the area under this figure from x is equal to 1 to x is equal to 4, which means he is basically concerned about this area. Now if you want to prove it generally, you know that these are three rectangles of same width but of different height. So initially you can go for is equal to area of this first rectangle. So if I call this rectangle as first, this as second and this as third, then area of this rectangle is 1 because 2 minus 1 is 1 into this height is 1 because the functional value of this function when x is in between 1 and 2 is 1. So 1 into 1 plus similarly what is the area of this rectangle? This width is 1, it's constant, but its height is 2 this time because for every value of x in between 2 and 3, the integer part x function value goes to 2 plus 1 into 3 for this third rectangle. So 1 into 1 is 1 plus 1 into 2 is 2 plus 1 into 3 is 3, and so the answer is 6. So this is one way in which you can declare the answer of this function is 6. Suppose if you look at integral 0 to integral 1 to 4 integer part x dx, because we know integral a to b f of x dx gives the area bounded by the curves y is equal to f of x and x axis. So you know, since this function by this graph is discontinuous or its limit does not exist at these integers, you will be splitting this function at all integers. Dx plus 2 to 3 integer part x dx plus integral 3 to 4 integer part x dx. And you know integer part x value when x is lying in between 1 and 2 is 1. So this integration is basically 1 dx plus integral 2 to 3. Whenever x is lying in between 2 and 3, integer part x value is 2. So it is 2 dx plus integral 3 to 4. Whenever x is in between 3 and 4, integer part x value is 3 dx. So this is equal to integration of 1 is x within the limits 1 to 2. This 2 is a constant and integration of 2 is 2x within the limits 1 to 2. Similarly here 3x, sorry, here the limits are from 2 to 3. Similarly here the limits are from 3 to 4. So if you do 2 minus 1 is 1 plus 2 into 3 minus 2 is again 1 plus 3 into 4 minus 3 is again 1. So the answer is 6. These are both ways in which you could evaluate the value of this function. So in both the ways the answer we get is 6. So option D is the answer for this. Okay. Thank you all. So we'll be looking at next question. So this is one more question that came in mathematics. So the question is the Laplace inverse of f of s is equal to 1 by s square plus omega square. So generally for any function f of t, the Laplace transform is generally given by some function in s domain, f of s. And the basic definition of Laplace transform of this f of t is integral 0 to infinity e power minus st into f of t dt. This is given as Laplace transform of this function f of t. So now if you see the Laplace transform of sine omega t, it can be evaluated as omega by s square plus omega square. Okay, so this is what we'll get if you calculate the integration, integral 0 to infinity e power minus st into sine omega t dt. So this is what the value you will be getting when you evaluate this integral using standard integration techniques. Now we can write this L of sine omega t as omega by s square plus omega square. Correct? S square plus omega square. Now see here, which means I can write this sine of omega t is equal to L inverse, which means Laplace inverse of, see this Laplace which is applied here is going to the other side, omega by s square plus omega square. And you know, since this omega is a constant, this can be brought out of this Laplace inverse function. So sine omega t is equal to omega into Laplace inverse of 1 by s square plus omega square. Correct? So what about sine omega t by omega? This is Laplace inverse of 1 by s square plus omega square. Okay. So this is what it was asked in the question. What is the Laplace inverse of 1 by s square plus omega square? So when this is f of s basically, which is sine omega t by omega, which is option D. So for this question, the answer is option D. So stay tuned, we'll go for next question. Thank you. So this is one more question which came in GATE this year. So for 0 less than or equal to x less than or equal to 1 and when m is greater than 1, how does these two graphs look like? Because graph of these two functions, x power 1 by m and x is x power m. Now it's given m is greater than 1, which means 1 by m will be obviously less than 1. Correct? And you know, when x is in between 0 to 1, which means when x is a decimal number between 0 and 1, higher powers of x, which means this is less than x when m is greater than 1. Correct? Because if you generally take x is equal to 0.5, if you calculate x square value, 0.5 whole square will give you 0.25, which is less than 0.5. Correct? So 0.5 whole square is less than 0.5 generally if you take some value. And similarly this case will be altered, means 0 less than x power m when m is less than 1. Like for example, if you take x is equal x power 1 by 2 when x is equal to 0.5, then this implies root x is equal to 0.5 under root, which is equal to 0.707, because we know the value of 1 by root 2 is 0.707, which is more than 0.5 greater than x. So this is the case when generally x power m value depends upon the value of m, and when m is greater than 1, this x power m is less than x, and when x is less than 1 means in a fraction power of x, this x power m will be greater than x. So now generally if you draw y is equal to x graphs for all of this, y is equal to x. Similarly, y is equal to x, and also y is equal to x, and here also y is equal to x. If you talk, so this x power m is less than x when m is greater than 1. So the line or the curve x power m should lie below y is equal to x. But in this option D, this y is equal to x power m is lying above. So this is a wrong option. Similarly here, this x power m line is falling. Okay, here this can be a case. And here if you see, again x power m is lying above y is equal to x. So this is also a wrong option. And now out of these two options, if you see, this y is equal to x power 1 by m, which means 1 by m when m is greater than 1 should be greater than x. Yes or no? Which means this y is equal to x power 1 by m line should lie above y is equal to x, and which is not the case here but only here. So option A is the correct answer. So the correct option for this is option A. And remember one thing, this is only the case when x is lying in between 0 and 1. Now suppose if x can cause 1, then you see by graph here, these two curves intersect here like this. That's all. So when after x is greater than 1, actually sorry, this could not be the icon for this, something like this. So when x is greater than 1, this higher powers of x causes this y is equal to x, and situation is altered. In that case, this could be the option, x power m comes onto the top. Thank you all. So this is our next question which came in Forenoon session of GATE. So if two real valued square matrices of same order are multiplied, then the product will be what? Means what's the condition of the product? Now first of all, generally in matrix multiplication, if you consider this matrix multiplication, the commutative law need not hold good, means AB and BA, these two need not be same. Need not be same. And to be correct, sometimes even if AB is existing, this BA may not exist depending upon the orders. But for this particular question, since they given both are square matrices of same order, both AB and BA exist, but they need not be same. So which means commutative law doesn't hold good. Commutative law doesn't hold, or you can term need not hold. Okay. Similarly, if you multiply three matrices A, B and C, then if you multiply this AB first and then multiply C with this, or if you multiply A to the product of BC multiplying together, this will be always same in matrices. But here the number of operations required to calculate this ABC may change when you multiply AB first and when you multiply BC first. But the end product, the two matrices that you evaluate using these two ways will be same always, which means associative law holds, associative law holds good for matrix multiplication. Now if you talk about third option, can't be evaluated. Here in this particular question, both AB and BA can be evaluated because it's given both A and B are square matrices of same order. So for third option, both AB and BA can be evaluated, because generally for matrix multiplication, what is the condition? If A is of order m by n and B is of order n by p, then matrix multiplication will hold only if number of columns in A is equal to number of rows in B. And since both these are square matrices of same order, here definitely these two are same and both AB and BA will be existing, which means this is not a right answer. So now coming to fourth option, what is the term positive matrix denote? A is equal to Aij, generally denoted by m by n, is called a positive matrix if Aij is greater than 0 for all I comma j. Means where of course this 1 less than I less than or equal to m and 1 less than or equal to j less than or equal to n. Okay. So this is a positive matrix, but depending upon the elements in the matrix, this multiplication need not be positive numbers. I mean need not give positive numbers for all the elements, correct? So we are not sure about this option, as well as this can't be evaluated is wrong, since in square matrices of same order this multiplication is possible. This is also wrong, and we know that matrix multiplication is not commutative, so this is also wrong. But you know, this associative law holds good in matrices, which means matrix product or matrix multiplication is associative, and this option best suits this question. Thank you all. So this is our next question, which came from probability distributions. So the question was like this: if x and y are exponential distributions functions of random variable, if z is equal to x plus y and the mean of x and y are 0.5 each and variance of z is 0, then the correlation between x and y is dash. So basically this correlation coefficient, or simply called as correlation, is used to determine how well these two variables x and y are related to each other, and theoretically the value can be in between -1 to 1. So such kind of question is given in which there are two random variables and we need to find the correlation between them. So let us see how to solve this question. Okay, so solution, and it's a numerical type question it was given. So let us see. So if you see, x is exponentially distributed with mean. What's the mean given? Mean is equal to 0.5 because it was stated with mean of 0.5 each. So generally for mean we can take this mean as 1 by lambda is equal to 0.5, and we know in exponential distributions mean is equal to variance power 1 by 2 in exponential distributions. So we have variance. Let us call this variance as sigma x square because this is variance of the random variable x. So this is equal to square of mean, which is 0.5 whole square, which is equal to 0.25. Correct? So similarly, if you write for y, similarly we get sigma y square is also mean square, which is 0.5 whole square, which is 0.25. Correct? So which is, you know, square root of variance is nothing but standard deviation, and in exponential distribution, as we know, this mean is equal to standard deviation. So if you want to write the variance of this z, where z is equal to x plus y, means variance of this x plus y, we have the formulation variance of ax plus by is equal to a square into variance of x plus b square into variance of y plus 2ab into covariance of x comma y. What is this covariance of x comma y and all? We'll see. Now this, suppose here in this equation z is equal to x plus y, we have a is equal to 1 and b is equal to 1. So therefore variance of z is equal to variance of x plus y is equal to, so if you put a is equal to 1 here, this is nothing but variance of x, plus similarly if you put b is equal to 1 here, this is variance of y, plus 2 times, when a is 1 and b is 1, a into b is 1, so this is into covariance of x comma y. And if you see, this variance of z is given as 0, which means this term what we are talking about, this particular term is 0. So this implies covariance of x comma y is equal to minus variance of x plus, means minus, if you shift this both sides, variance of y divided by 2. And if see, what is variance of x? 0.25. So minus 0.25 minus variance of y is also obtained as 0.25 divided by 2. So which is minus 0.25. So the covariance of x comma y, therefore covariance of x comma y is obtained to be minus 0.25. Now the correlation between x and y, the correlation coefficient is generally denoted by rho, and rho x comma y is nothing but covariance of x comma y divided by sigma x into sigma y, where sigma x is the standard deviation of the random variable x and sigma y is the standard deviation of the random variable y. So this is equal to, see, covariance of x comma y, we just obtained this value as minus 0.25. So if you put minus 0.25 here, and if you divide this with, see, when sigma x square is 0.25, sigma x is 0.5, and similarly here when sigma y square is 0.25, sigma y is also 0.5. You may doubt why I'm not taking the minus sign here, because in exponential distributions we have this mean is equal to standard deviations, means basically sigmas. So when mean is given 0.5, the standard deviation also it's 0.5, and if you cancel, this is nothing but 0.25, and minus 0.25 divided by 0.25 is minus 1. So therefore the correlation coefficient of x comma y is minus 1. Okay, so basically the answer that we should get is minus 1. Thank you. We'll go for next question. So this is the question from Simpson's one-third rule. The question was like this: solve the following integration by Simpson's one-third rule for this integration, where I is equal to minus 1 to 1.4 x into mod x dx, and h is equal to 0.6, where h is generally the step size of the integration that we carry, and this h is basically this b minus a divided by n, where b is 1.4 and a is minus 1. So similarly, when n is equal to b minus a by h, so n is equal to b, as we told it's 1.4 minus of this minus 1, which is plus 1, divided by this step size h 0.6 gives you 4, because 2.4 by 0.6 is 4. Now if you look at this function x into mod x generally, look, suppose if y is equal to x into mod x, we know this is x into this mod x value is x when x is greater than or equal to 0, and x into this mod x value is minus x when x is less than 0, which is equal to x square for x greater than or equal to 0 minus x square, which is x less than 0. Which means if you try to plot this function like this, you can find something like 0 x y minus x, and this is minus y. So if you try to plot this for x less than 0, which means to the left of this y-axis, the curve is minus x square like this. Y is equal to minus x square. And to the right of this y-axis, the curve is y is equal to x square. So y is equal to x square. So this is how curve looks, and if you see, this curve is completely differentiable, and also of course it's continuous and also differentiable in this given range of minus 1 to 1.4. So for example, let us call this particular value as x is equal to minus 1, and this value of x, this is x is equal to 1.4. So this function is continuous, and so we don't have any issue in applying this Simpson's one-third rule. So if you look at the solution of this function, of this problem, so by Simpson's one-third rule, we have the formulation as h by 3 into sum of extreme values of y, means y0 and yn, which means this value y0 and this value which is y4 here. So y0 plus y4 plus 4 times of odd subscripts, means y1 plus y3 plus 2 times of this even subscripts, which is y2. So this is the formulation that we have for general Simpson's one-third rule. So if you substitute these values now, what's the value of h that we obtained? It's 0.6. So 0.6 by 3 into y0 plus yn, which is minus 1 plus 1.92 plus 4 times of y1 plus y3, which is minus 0.16 plus this value is 0.64 plus 2 times of y2. This y2 is 0.04. So if we do this calculation, 0.6 by 3 into this minus 1 plus 1.92 will give you 0.92 plus 4 times of this minus 0.16 plus 0.64 will give you 0.48 plus 2 times of 2 into 0.08 is, okay, it's 0.04. Fine. Since we are not multiplying this 2, so this is equal to, see, this 0.6 divided by 3 will give you 0.2. So this is 0.2 into, this is 0.92 plus 4 into 0.48. So 4 8s are 32, 3, 4 4s are 16, 17, 18, 19. So this is 1.92 plus this is 0.08. So which is 0.2 into, look, 0.92, 1.92 and 0.08, which is 2.92. Correct? So 2.92. This is equal to, if you multiply this 2.92 with this, so 2.92 into 0.2. 2 2s are 4, 2 9s are 18, and 1 2 2s are 1, which is 5. and which is 0.584 because we have 3 decimals there. So the answer for this is 0.584, which means the value of this integration I is equal to integral minus 1 to 1.4 x into mod x dx, which when evaluated using Simpson's one-third rule is 0.584. So the answer for this is 0.584. Okay, so we'll be looking at our next question now. So please stay tuned. Thank you. Okay, so this is the next question which came in GATE this year. So this question is basically from complex variables, and you can see which of the following function is not an analytic function. And we have 4 different functions given in 4 different options. So basically, if your function want to be analytic, what's the meaning of analyticity? We call a function to be analytic if, suppose, if this is a complex plane x comma y, where x is plotting real axis of complex number and y is plotting imaginary axis of complex number, then if you take any point z here, then we call f of z is analytic at this point z if this function f of z has derivative at this point z and also at every point in the neighborhood of z. So this is the basic definition of analyticity. And the normal rules for differentiability of complex functions is same as rules for differentiability of real valued functions. Means in real calculus we know all polynomial functions like x power n, when of course n is greater than 0, and e power x, similarly x power n, e power x, and sin x, cos x, we know all these functions are generally differentiable at all points on the real number plane. So similarly we have this z power n, of course n greater than 0, e power z, sin z, cos z, all these functions are differentiable at each and every point of the complex plane. So generally if you look at this point, this e power z, which is e power x plus iy, because z can be written as x plus iy, is analytic at every point. Similarly this sin z can be written as sin z is equal to e power iz minus e power minus iz divided by 2, because we have e power iz is equal to cos z plus I sin z, correct, as per Euler's formula in complex variables. So e power minus iz can be written as cos z minus I sin z. So if you subtract these two things, this cos z gets cancelled, and e power iz minus e power minus iz is equal to 2i sin z, and this implies sin z is equal to e power iz minus e power minus iz divided by 2i. So we'll put an I here, which we didn't actually. So here e power iz is also differentiable and e power minus iz is also differentiable. So this sin z is also differentiable at every point. A is also differentiable at every point. Similarly, if you look at this higher powers of z, means basically integer powers of z, this function is also differentiable at every point. But this log z, you see, what is the differentiation of this log z? 1 by z, which is not differentiable at x is equal at z is equal to 0. Okay, so this function is not differentiable at z is equal to 0, and we say that this function is not analytic on the complex plane. And also one more important thing is, this functions, if it's analytic, it should satisfy some equations called CR equations, which are called Cauchy-Riemann equations. And what does this Cauchy-Riemann equation say? If f of z is equal to u plus iv, then for the function to be analytic, this dou u by dou x should be equal to dou v by dou y, and dou v by dou x or dou u by dou y is equal to minus dou v by dou x. And generally if you write this log z, we will be getting log z to the base e is equal to half of x square plus y square plus I into tan inverse of y by x. So this is what you will be getting. So if you treat this as u and this as v, we find that this equations get satisfied for all values except x is equal to 0. So this C is the option C, log z to the base e is not differentiable at z is equal to 0, because these equations fails when xy values are zeros for this equation. So the option is option C. Option C, log z to the base e. Thank you. Stay tuned, we will be looking at next question. So this is another question from complex calculus, and it's given like when z is equal to x plus iy and f of z is equal to x square minus y square plus I into psi of x comma, means this is one function in terms of x and y. Then the value of imaginary part of f of z, means basically he's asking the value of psi of x comma y when at z is equal to 1 plus I, if f of z is analytic. Now look one thing, we want psi, correct? So we have d psi is equal to dou psi by dou x into dx plus dou psi by dou y into dy, because it's a function of two variables and this is as per total chain rule. So this implies this d psi is equal to, see, we don't have any evaluation of psi of x comma y, means we don't have any function to substitute this dou phi by dou x, but it's given one important word here, which is this function f of z is analytic. So if f of z is equal to u plus iv is analytic, then we know that if a function is analytic, the necessary condition is it should satisfy the Cauchy-Riemann equations, which are given as dou u by dou x is equal to dou v by dou y, and dou u by dou y is equal to minus dou v by dou x. So which means in place of dou v by dou x, I can substitute minus dou u by dou y, which means dou v by dou x is equal to minus dou u by dou y. Similarly, in terms of dou v by dou y, I can substitute dou u by dou x from first equation, correct? So similarly in this case here, when I don't have information about this dou psi by dou x, I can substitute this dou psi by dou x as minus dou this function divided by dou y. So minus dou by dou y of this particular function x square minus y square dx, correct? Plus here dou v by dou y, which means dou psi by dou y in this case, and this dou psi by dou y by Cauchy-Riemann equations can be written as dou u by dou x, which means dou by dou x of this function here x square minus y square dy, correct? So this is minus dou by dou y of this function is minus 2y dx plus dou by dou x of this function is 2x dy, so which is equal to 2y dx plus 2x dy, which if you want you can write this as, this is nothing but y square, this can be written as d of 2xy, correct? Because this 2 is a constant and this is y dx plus x dy, which is differentiation of xy, and this 2 is a constant which is same if it brought out or inside of this differential. So this means we have this d psi is equal to d of 2xy, which means we have this psi is equal to 2xy, this function psi, correct? Now he is asking when the value of z is 1 plus I. Look here, look carefully, when z is equal to x plus iy, it's given here in the beginning of the question, and now it's being told this is 1 plus I, which means x is equal to 1 and y is equal to 1. So if you calculate this psi of x comma y value when at values of x is equal to 1 and y is equal to 1, this implies psi of x comma y at 1 comma 1 is equal to 2xy at x is equal to 1 comma y is equal to 1. So this is equal to 2, correct? So which means because when you put x is equal to 1 and y is equal to 1, this value is 2. So the value of this imaginary part of f of z, which is 2xy when x is equal to 1 and y is equal to 1, is 2. So the answer for this question is how much? 2. Okay. So here simple logic is to apply the Cauchy-Riemann equations and to evaluate this function psi, which we want to evaluate. Okay. Thank you all. So this is one of the questions from vector calculus, and if you see, this is based on evaluation of the double integral. So double integral f bar dot ds bar, and here the vector field is given by this particular vector, where this is f bar of xyz is equal to x by, and if you see this term, the term x square plus y square plus z square whole power 1 by 2 is nothing but magnitude of the vector xi bar plus yj bar plus zk bar, correct? We know this. So this is cube of the magnitude of the position vector. Similarly here y by the same term which came here, and z by this term. So we want to evaluate this integral. Now if you see, if you look at the surface, it's given this is evaluated over the inner and outer surfaces of the spherical shell, which is formed by two concentric spheres with origin as the center and the internal and external radii of 1 and 2 units. Means if you take two concentric spheres like this with internal radius of 1 unit and external radius of 2 units, then this is evaluated. This means this vector f bar is evaluated along this inner integral I mean along this inner surface and also along this external surface. So if you see, these two surfaces are basically closed. So which means for the evaluation of double integrals or surface integrals, when the surface is closed, we can use Gauss divergence theorem. And what does Gauss divergence theorem tells us? Let us see. For double integral over the surface S, f bar dot ds bar is equal to triple integral over the volume V divergence of this particular vector f bar into dV when the surface is closed, and if this surface S which you are talking is bounding a finite volume V. So here the main important thing is now to find what is the divergence of this particular vector. So if we know what is this divergence of vector, then we can substitute here and we can evaluate this value. So let us try to find what is divergence of f bar. This is nothing but cyclic integral of dou by dou, summation of dou by dou x of x by x square plus y square plus z square whole to the power 3 by 2. And now if you differentiate this, we will be getting y with respect to x partially, you will be getting y square plus z square minus x square into 2 divided by x square plus y square plus z square whole cube. This is the term you will be getting if you differentiate this expression partially with respect to x. So if I write this once again, y square plus z square minus 2x square divided by x square plus y square plus z square whole cube. Since we are adopting summation here, we can adopt here and as well as here. So if you see, this is a cyclic term, which means when you differentiate with respect to x, you will be getting y square plus z square minus 2x square. Similarly, if you put y here, means for the second term which is given here, if you put y here and if you differentiate with respect to y partially, you will be getting the next term as x square plus z square minus 2y square divided by x square plus y square plus z square whole cube. So this total summation will give you 0 because this is cyclic expression, and when you run the sigma summation to over this, you will be getting 0, which means basically you will be getting divergence of this f bar is equal to 0 for this particular case of f bar. So when this divergence of f bar is 0, and if you put 0 in place of this divergence of f bar in this integral, your answer is 0, because 0 into something, our integration is 0. So the answer is 0 for this question, and this is how things happen. Thank you.